The next scheduling algorithm is multi-level queue scheduling. This class of scheduling are used in a situation where the process can be classified into different groups. Okay, so the process are permanently allocated to a queue based on some of its property, maybe with the memory size or process priority or process type. One unique feature of this kind of scheduling is that each queue has its own scheduling algorithm. There should be scheduling among the queues, which is commonly a fixed priority preemptive scheduling. That is, if you're considering these are the queues, the system process is the one with the highest priority and student process is the one with the lowest priority. So if a process has to be executed and if it is in the batch process, then all these queues should be empty. Okay, only if all this queue is empty, a process in batch process can work. Now consider if a process is running in the batch process and there is a new process that entered. This process is classified into interactive editing process, so that has a higher priority. So what happens, the process in the batch process will be preempted and the process that have came in a higher priority queue is executed. Okay, another possibility of preemption is that you can allocate time slice. For example, if there is two groups, that is foreground process and background process, we say that the foreground process get 80% of the CPU time and the scheduling algorithm used is round robin, and in background process queue you say it only gets 20% of CPU time and it goes with the scheduling algorithm FCFS. So this is how multi-level queue scheduling works. The problem with this scheduling algorithm is that once the process is allocated to queue, it will permanently stay in that queue. So process with lower priority may affect with starvation. The next scheduling algorithm is multi-feedback queue scheduling. So in the scheduling algorithm, we will be solving the problem with our earlier multi-level scheduling algorithm, where the process are permanently associated with a queue. In multi-level feedback queue, it allows a process to move between the queues. So basically it is based on a characteristics CPU burst. So process are put into different queue based on the CPU burst. If the process has too much CPU time, it will be moved to the lower priority queue, and if the process waits too long in a lower priority queue, then it will be moved to a higher priority queue. So the process with higher CPU burst time are put into lower priority queues, and if the process is staying in that lower priority queue for a very long time, then it is brought back to the higher priority queue. So a process is given to queue 0 with a time life 8 millisecond. So it will run for 8 milliseconds. If it is completed, fine. If it's not, then it is allocated to the tail of the Q1. So here it is given 16 millisecond, and in this queue the execution starts from the head. Okay, here also the execution is starting from the head. If the process hasn't completed within the 8 millisecond, then only it will be allocated to Q1. Then all the process from here it will start executing. Still, if the process has some more remaining time to be executed, then it is allocated to the Q2. So in this queue, the scheduling algorithm is FCFS. Okay. The process with higher priority are those process which has 8 milliseconds, and the next priority goes to process which has CPU burst greater than 8 milliseconds but lower than 24 milliseconds. Multi-level feedback queue schedulers are defined by 5 different characteristics: the number of queues, the scheduling algorithm used for each queue, the method that is used to determine when to upgrade a process to higher priority queue, the method that is used to determine when to demote a process to lower priority queue, and the method to determine which queue a process will enter when that process needs service. So with all these 5 characteristics, you define a multi-feedback queue scheduler. And this is a very complex algorithm, but still it is the most general CPU scheduling algorithm. By this, we will come to an end to CPU scheduling algorithms. So from the next video onwards, we'll be speaking about deadlocks.